Now, let's proceed.
For today, we will discuss and you will learn about how to multiply and divide a polynomials containing radicals. So, let's start.
Now, let's proceed.
Our first example in multiplying polynomials containing radical is this. Letter A, 6 square root of 3 times 4 square root of 15. Now, the first step is we will multiply the number outside the radical, which is 6 and 4. 6 times 4 is equal to 24. Next is the number outside the radical, or what we call radicand. We will get square root of 3 times square root of 15 is equal to square root of 45. Now, we need to get the perfect square root of 45, which is square root of 9 times 5. Then, copy the 24. We need to get the square root of 9, which is 3. Then, we will put it outside the radical. Then, multiply it to the number that is located outside the radical, which is 24. 24 times 3 is equal to 72. Equal 72. Then, copy the square root of 5, which is left behind. Then, that is the answer, 72 square root of 5.
Now, let's proceed.
Proceed to the another example, letter B. 2 4th root of 9x cubed y squared times 4th root of 27x raised to 5 y raised to 7. In this case, they have the same index, which is the 4 or 4th root. We need to multiply the 9 times 27. The product is 9 times 27 is equal to 243. Next is the variable, which is the x. X cubed times x raised to 5 is equal to x raised to 8. In variable or in the exponent, if we will multiply the exponent, we need to add this. Next is y squared times y raised to 7. If we will multiply y squared times y raised to 7, we will get y raised to 9. Then the 4th root. Then copy the 2. Now, we need to get the greatest 4th root of 243, which is 81 times 3. Then, copy the variable, which is x raised to 8, y raised to 9, then square root, then copy the 2. Then, we need to factor the 81. What is the 4th root of 81? It is 3. Then, we need to put the 3 outside the radical, then multiply it the number located outside the radical, which is the 2. 3 times 2 is equal to 6. Then 4th root of the left behind number, which is the 3. Then we need to put outside the 4th root of x raised to 8. We will write this as x times x times x. Then the 4 count of x will be counted as 1, so it is equal to 6x squared because it is 2 sets. Next is the y raised to 9, which is y squared. Then the other y will left behind the radical. So the answer is 6x squared, y squared, 4th root of 3y.
Now, let's proceed.
Now, let's proceed to the third example of multiplying. In this example, we will apply a distributive property of radicals. We will distribute the square root of 3x in binomial square root of 12x plus 4. The square root of 3x times square root of 12x is equal to square root of 36x squared. Then square root of 3x times 4 is equal to 4 square root of 3x, because it doesn't contain a radical, so that we can multiply at 3 times 4. Next, we will factor the 36x squared. What is the square root of 36? It is equal to 6. Then what is the square root of x squared? It is equal to x. Then what is the square root of 3x? It doesn't have a square root because 3 times 3 is equal to 9. Then the square root of x is x squared. So that we just need to copy the 4 square root of 3x. Then that is the final answer.
Now, let's proceed.
Now, let's proceed to the last example of multiplication. In this given, we have the 2 binomials square root of 2 plus 3 times square root of 2 minus 4. In this given, we need to apply the FOIL method. The first, we need to multiply square root of 2 times square root of 2. We have square root of 4. The second, or the outer, we need to multiply negative 4 times square root of 2. The answer will negative 4 square root of 2. The inner is 3 times square root of 2. The answer will be 3 square root of 2. Then the last is 3 times negative 4 is equal to negative 12. We need to combine like terms, or we need to simplify each answer. Square root of 4 is equal to 2. Negative 4 square root of 2 plus 3 square root of 2 is equal to negative square root of 2. Then the last, or the last given, or the answer is negative 12. We need to copy. Then simplify. Combine like terms. 2 plus negative 12 is equal to negative 10. Then we just need to copy the negative square root of 2 in order to get the answer. The answer is negative 10 minus square root of 2. Now, let's proceed in dividing a polynomials containing radicals. In this given, we have 4 square root of 8x raised to 5 divided by 2 square root of 2x squared. In first step, we need to divide the 4 divided by 2 outside the radical. 4 divided by 2 is equal to 2. Then, we will divide the radicand, or 8x raised to 5 divided by 2x squared. When we divide x by 8 by 2, we will have 4. Then x raised to 5 and x squared, we will have x cubed. Because in dividing an exponent, we need to subtract it. So we have 2 square root of 4x cubed. What is the square root of 4? We have 2. Then the 2, we will put it outside the radical. Then we have 2 times 2 is equal to 4. What is the square root of x cubed? We have x, because 2 is equal to 1. 4x, square root of x, that is the final answer, because in x cubed, we will left behind a 1x. So the answer is 4x square root of x.
Now, let's proceed.
Now, let's proceed to the second example of division. We have here 7 over square root of 5, or 7 divided by square root of 5. In this case, we need to rationalize the denominator, or multiply it by the denominator square root of 5 times square root of 5 in order to remove the radical sign located in the denominator. 7 times square root of 5 is equal to square root of 5 over square root of 25. Here, in square root of 25, when you square root the 25 inside the radical, we have 5 over 7 square root of 5. Then that is the answer. We just need to remove the radical sign here in the denominator. So the answer is 7 square root of 5 over 5.
Now, let's proceed.
Now, let's proceed to our last example of dividing a polynomials containing radicals. Here, we have a given 3 divided by square root of 2 plus 1. As you can see, we have here a binomial. Here, we need to multiply it by its complex conjugate. It is written as square root of 2 minus 1 over square root of 2 minus 1. Because the complex conjugate of square root of 2 plus 1 is square root of 2 minus 1, we need to change the operation or the sign. Here we have an answer. We need to distribute 3 in square root of 2 and negative 1. 3 times square root of 2 is equal to 3 square root of 2. Next, 3 times negative 1 is equal to negative 3 over In multiplying a binomial with its complex conjugate, we just need to multiply the first term and the second term. We don't need to compute overall in quadratic formula. So, square root of 2 plus 1 times square root of 2 minus 1 is equal to square root of 2 times square root of 2 is equal to square root of 4. 1 times negative 1 is equal to negative 1. Here we have 3 square root of 2 minus 3 over the square root of 4 is 2 minus 1. So we have here, copy the 3 square root of 2 minus 3 over 2 minus 1 is equal to 1. So the answer is 3 square root of 2 minus 3 because the over 1 is a whole number. So this is only the answer.
Now, let's proceed.
Thank you for watching and please like and share this video.